Start by creating a new circuit, changing the file name to something meaningful, in this circuit we'll use a capacitor to enable us to have an LED that we turn on, and then when we release the push button, the LED will stay on for a period of time and fade. And that's because the capacitor actually holds a certain amount of electricity and slowly lets that electricity out, and that will feed the circuit. So we'll be using the circuit fading LED circuit from our guide, and the addition of the parallel circuit with the capacitor will allow the flow of electrons. Once we stop adding electrons directly to the circuit with the LED, once we release that, the electrons will be able to flow out of the capacitor and through the LED temporarily, almost like having a short-term battery. So for our components, we will require a resistor, an LED, push button, our battery. We need a different type of capacitor than is showing up on our basic components here. So I'll type in capacitor. I want to use this polarized capacitor. And I also need to get my breadboard. There it is. Oh, picked up my LED inadvertently. All right, let's start to build the circuit as we saw it in the diagram. Now, interpreting this requires a little bit more than just putting things in the same spot. I'll start by placing my push button. My LED I will need to rotate, and I will place that over here. I'm going to need my capacitor. I will put it right here, and my LED will need to go from my resistor. Now just change the color of my wires here. I will need one that leaves my capacitor and goes also up to that area. I'll just double click on that so I can put a bit of a bend in it so it's a little bit more clear. And I will need some wires to connect my ground. Oh, didn't do that from ground. Ground to my push button. Now I'm going to need to connect, so this will allow the flow of electrons. When I press the button, I need them to flow from my push button all the way to my capacitor, but I also need them to flow from that point to my resistor. Now what's not so evident here, and I still need to connect my battery, but what's not so obvious with the flow here is that when my electrons come through my switch, they flow along this wire through my resistor, light up my LED back to my battery. When I'm pushing this button, I'm also sending electrons into my capacitor, so they're getting a charge, or it's getting a charge. But when I cease to be holding this push button, this would still be connected, that they can flow out of here and then to my LED until I take out my supply that's in the capacitor. So that's how this idea of a temporary storage of electrons as possible. Let's connect my battery. Guess I was still clicked on that when I changed colors. There we go. Before we start our simulation, let's just check the value of our capacitor. So by default, it was set to 1 microfarad. We need to change this. So this circuit will work. It needs to be 1,000 microfarads. And let's go ahead and try our simulation. So initially, no electrons flowing to the LED. I push my button and it fades relatively quickly. If I hold it a bit longer, fades. So it looks like if I hold it long enough, it fades. It takes a little bit longer to fade, but if I changed out my capacitor, I'd be able to get a greater storage. So that's something we can play with, is changing the value of our capacitor to see how that impacts how long it takes for the LED to actually fade away. In this circuit, I also used a 400 ohm resistor like we had used at the end of our previous circuit with the LED.